Hello students, very good morning. Myself Shah from ULJ Institute of Engineering and Technology. Today we are going to discuss subject Mathematics-1 with the topic gradient and directional derivative. So let's start our topic gradient. The gradient of a function x, y, z therefore x, y and z is written as f is written as grade f and it is denoted by the symbol delta f. Okay, so and it is defined by gradient of f, that is grade f, symbol is this guys, delta f is equal to I del f by del x plus j del f by del y and k del f by del z. So this is the formula for finding the gradient. Now the directional derivative. So the directional derivative of a function f of x, y, z in the direction of the vector a bar, that is defined by directional derivative of f, it is gradient of f dot unit vector a, and unit vector a is the vector a upon the determinant of vector a. So students, these are the definitions of the gradient and the directional derivative. Let's start the example of the gradient and directional derivative for the better understanding. So let's start with example 1. Find gradient of f at the point 1, minus 2 and 1 if f is equal to 3x square y minus y cube z square. So let's start the solution here. Here given function f is 3x square y minus y cube z square, and the formula for the gradient f, that is I del f by del x plus j del f by del y and k del f by del z. So I keep it same. The derivative of f with respect to x, here 6xy, plus the derivative of f with respect to y, 3x square minus 3y square z square, and the derivative of f with respect to z, that is minus 2y cube z. We want to find the gradient of f at the point 1, minus 2, 1. It means we have to replace x by 1, y by minus 2 and z by 1. So the gradient of f at the point 1, minus 2, 1, that is, I keep it same, 6 in the place of x is 1, y is minus 2 plus j, here 3, 1 square minus 3 minus 2 square and z is 1 square minus k 2 minus 2 cube and z is 1. So after simplification our final answer is minus 12i. This is 3, here minus 2 square is, that is 4 and minus 3 minus 12 plus 9, so minus 9j, and here minus 8 into 2, so 16, and minus plus, so plus 16k. So students, this is the final answer of the gradient of f at the given point 1, minus 2 and 1. Let's move with one more example, that is example 2. And here find the directional derivative of f equal to xy square plus yz square, f equal to xy square plus yz square at the point 2 minus 1 1 in the direction of the vector I plus 2j plus 2k. So let's start the solution for the given data. Here our given function f is xy square plus yz square, and first we want to find the gradient of f, and that is gradient of f is I del f by del x plus j del f by del y and k del f by del z. So the derivative of f with respect to x is here y square, and the derivative of j keep it the same, and the derivative of f with respect to y here 2 xy plus z square, k keep it the same, and the derivative of f with respect to z here 2yz. Now we want to find the gradient of f at the point 2 minus 1 1. So by putting x is equal to 2, y is equal to minus 1 and z is equal to 1. So the gradient of f at the point 2 minus 1 1, that is I, here y is 1, so minus 1 square plus j 2, x is replaced by 2, y is replaced by minus 1, z is replaced by 1 plus k, here this is 2, y is minus 1 and z is 1. So this is minus 1 square, so I, here minus 3j minus 2k. So final gradient of f at the point 2, gradient of f at the point 2 minus 1 and 1 is I minus 3j plus, and this one is minus 2k. Okay, now the directional derivative in the direction of the vector and our given vector is I plus 2j plus 2k, that is I plus 2j plus 2k. So the directional derivative of f here, gradient of f at the point 2 minus 1 1 into a upon, this is vector n, this is a determinant of vector a. So gradient of f at the point 2 minus 1 1 is I minus 3j minus 2k, and the given vector, that is I plus 2j plus 2k, and determinant, that is coefficient of I, that is 1, here 1 square is 1, coefficient of j, that is 2, so the square of 2 is 4, and the coefficient of k, that is again 2, so the square of 2 is again 4. So in the denominator, square root of 9 is 3, but in the numerator, the dot product, we have I, a dot I, that is 1, here 1, minus 6 and minus 4 upon square root of 9. So up in the numerator, minus 9 by 3, So our final answer is -3. Students, let's move with one more example, that is example 3. Here, evaluate gradient of e raised to r square, where r square is equal to x square plus y square plus z square. So let's start the solution. R square is equal to x square plus y square plus z square. So the derivative with respect to x, y and z, that is 2r del r by del x. Here 2x implies del r by del x is equal to x by r. With respect to y, that is 2r del r by del y. Here 2y implies del r by del y is y by r. And similarly 2r del r by del z, that is 2z. So here del r by del z, it is z by r. Okay. Now, as per the formula of the gradient of del e raised to r square, that is I, del e raised to r square upon del x plus j del e raised to r square upon del y, and k del e raised to r square upon del z. So here we are using the chain rule, that is I, derivative of e raised to r square. First we are doing with r, that is del e raised to r square upon del r into del r by del x. Then j del e raised to r square upon del r into del r by del y, plus k del e raised to r square upon del r into del r by del z. So I, derivative of e raised to r square with respect to r, that is e raised to r square into 2r, and here x upon r, plus j e raised to r square into 2r into y upon r, and k e raised to r square into 2r into z upon r. So after simplifying, in all terms r will be cancelled, and after getting 2 e raised to r common, the remaining term is x into I plus y into j and z into k. So this is the final gradient answer for the given data. Students, today we learn about the gradient and the directional derivative. Feel free to contact me for any query. Till that, enjoy the study. Thank you.